This is the tutorial for the review of Chapter 10, Section 3, and Chapter 10, Section 4. So let's take a look at our first type of problem. And in these two sections, we're dealing with dividing terms with exponents. And so we've got a common base here, and that's what we have to have in order to use these exponent rules. And so notice that it says to write your answer as a power. And since we have the same base, we're just going to subtract the exponents, 24 minus 8. And basically what I'm doing is, if you picture 24 sixes across the page and then 8 sixes across the page here, these 8 sixes are going to cancel out 24, or 8 sixes from the 24, and that's how I'm left with 16 sixes altogether. And that will be my answer. On this next one, what we want to do is combine what's on top of the fraction. A fraction bar is actually a grouping symbol, and so it's kind of like having parentheses. And so it's saying do the work in the numerator first. And so what we have is a 3, and that's really to the first power. And what we're doing is we're adding up those exponents. 3 to the first and 3 to the 10th makes 3 to the 11th power. But then what we're doing is we are taking away some 3's because we are dividing. And so these 8 3's on the bottom are going to cancel out 8 3's on top, and I'm just left with 3 to the third power. So here it says simplify. So when it says simplify, we're going to actually multiply out any numbers. So if it was 3 to the third power, we'd multiply that out. So here first we see no numbers but just variables. And so we can't do anything with the p to the 7th power because there's no other p's in the problem, so we can't do any reducing. But there are some u's in this problem here on top and bottom. So what I'm going to do is I'm going to subtract those 9 u's, or I'm going to take away 9 of those u's from the bottom and take 9 of the u's away from the top. And what that leaves us with is 9 u's on top of that fraction. And so you can see how everything canceled out on the bottom, and we just have 1 left over. So typically we just write that as p to the 7th, u to the 9th. So on the next problem, we've got some 9's and t's. And so what we're going to do is treat this as two separate problems, just kind of like what we did here. But now I can reduce both terms. And so I've got these 5 9's I'm going to take away from the top of the fraction and from the bottom of the fraction. So that's going to leave me with 9 to the 8 minus 5. And do the same thing here. T to the 10th, I'm going to take away 10 t's from the top of the fraction as well, so 16 minus 10. And so when I do that work, I get 9 to the 3rd, t to the 6th. And so I can multiply out these 9's and do 9 times 9 is 81 times 1 more 9 gives me 729. So 729 t to the 6th power is what I'm looking for there. So on this next one, it says the average number of needles on a 20-year-old ponderosa pine is 4 to the 10th power. A sugar pine of the same age has 4 to the 18th needles, so a few more needles than the ponderosa. So it says how many times more. Okay, so right here it's going to tell us what we're trying to do. How many times more? So we don't know the number of times. That's the unknown. So how many times more needles does the sugar pine have than the ponderosa? So basically what we're doing is we're taking 4 to the 10th, we're multiplying it by some number that we don't know, because that's what they're asking for. How many times more? How many times more needles than the ponderosa? And what we're going to end up doing to solve that is I'm going to divide. And divide by 4 to the 10th. And so what that gives me is, since I have the same base, I can use that rule of subtraction of exponents. And so that's going to leave me with 4 to the 8th. So let's write some units there. So we'll say 4 to the 8th needles. Needles on 4 to the 8th needles. We'll say more needles. So let's go ahead and change that. 4 to the 8th, more needles on the sugar pine. So let's take a look at the next problem that we'll end up seeing. So here we've got more exponent rules, and now we've got negative exponents in the problem. And so we've got k to the negative 15th, k to the negative 16th. And they're going to say write the answer using positive exponents. And so our rule is that when we multiply, we add up the exponents. And so that's what I'm going to do here. So I have k to the negative 31st. Now to write it with positive exponents, the rule is that we take the reciprocal. And so it's going to be 1 over k to the 31st. So on this next one, we have 5 as the base, and we have to the negative 10th power over 5 to the negative 16th power. So again, we're just using the exponent rule, which says we are going to subtract the exponents. So negative 10 minus negative 16. So when I add the opposite, I end up getting 5 to the 6th power. Now that's already positive, so I don't have to do any taking of reciprocals. The next one says, how can you write the number 1 as 8 to a power? So we've got to take 8 and write a power for that. And what that power is going to end up being is 0. So what we'll end up finding out is that any number to the 0 power is just 1. And the way it works out is if I had 8 to the second over 8 to the second, well, using that exponent rule, I would subtract the exponents. And that's how I get 8 to the 0 power. Well, how is it 1? Well, just go ahead and multiply out these 8's. We have 8 times 8 is what 8 squared is. 8 times 8 is what 8 squared is, and you can see how those 8's cancel each other out. And when they cancel each other out, you get 1. And so that's why any number to the 0 power is going to end up being 1. And that's what we'll end up seeing is that concept there. Take a look at the next one. It says, simplify each expression. Write your answer using positive exponents. So I've got each of these parts I need to bring to the second power. So the negative 8 needs to be brought to the second power. So it's going to be negative 8 squared. It's in parentheses, so it's really negative 8 times negative 8 there. And then I have b to the negative 10th times by 2, and then times 2b to the negative 7th. So I'll multiply out these negative 8s, and that makes 64. And so I have b to the negative 20th times by 2, and b to the negative 7th. So I'm just using the exponent rules and the rules of multiplication. And I've got two coefficients here that I could go ahead and multiply together. I get 128. Now I'm going to use the exponent rule, which says I add up the exponents. Negative 20 and negative 7 add to make negative 27. So I have 128b to the negative 27th power. And so from that point, all I need to do is write it with positive exponents. And the rule is that you take the reciprocal of the negative exponents, and then they become positive. And so that would be our answer. 128 over b to the 27th power. On this next one, just have some more exponent rules. Look at the 81 and the 3. 3 goes into 81, and so that's what I'm going to end up doing right there, and do that division, and then I use the exponent rule. The exponent rule is subtract. Subtract the exponents when you've got division of with the same base, and that's what I'll do there. So I'll add the opposite, and dealing with this division gives me 27, and then I have p to the negative 12th power. And so when I did that subtraction, it's plus negative. I didn't see that plus negative there, so it's going to be negative 18. So let's fix that number right there. So we'll say p to the negative 18th power. And so I would write that as a fraction with positive exponents. I take the reciprocal of the negative exponents. So 27 over p to the 18th power is the answer there. So on this last one, it says a teragram is 10 to the 12th grams. Okay, so they're giving me the conversion factor there. Mass of a grain of sand is about 10 to the negative 4th grams. And so about how many grains of sand are in a silo that contains 1,000 teragrams. So the first thing we're going to do is change 1,000 so it's a power of 10. And so this is going to be 10 to the 3rd. So you just count up the zeros, 1, 2, 3, so that's 1,000. And then I'm going to take that number and multiply it by how many grams are in a teragram. So a teragram is 10 to the 12th grams. And then I'm going to divide by the grain, the mass of a grain of sand, which is 10 to the negative 4th. So we're trying to find how many of these grains of sand go into a teragram. And that's what we're ending up doing here. And actually into the silo, which has 1,000 teragrams, or capacity of that. And so this is 10 to the 15th power when I go ahead and add up these exponents. And from there, I do some subtraction. Now I've got the division, so I subtract the exponents. 15 minus negative 4. And when I add the opposite there, I get 10 to the 19th power. So 10 to the 19th grains of sand in the silo. That's what we end up saying there. So those are the types of problems that you're going to see on tonight's assignment. Good luck.